my name is Lauren Grant, and this is my Lab 2 lines of charge. So we're going to go through an intro, fundamental principles, the initial conditions slash assumptions, the glow script poll, questions, and then a conclusion. The purpose of this lab is to compare the point charge model, which was done in Lab 1, to the line charge model, where we divide up the tape, treat each separate piece of divided tape as a point charge, and then add up the charges on the separate pieces in hopes of getting a better approximation of the amount of charge on one piece of tape. The results of this is that the approximate charge on one piece of tape is 2.44 e to the negative 8 coulombs. The errors that may have occurred in me calculating this include that the charges on the piece of tape, as well as the distribution of charges on the tape, may not have been equal. Fundamental principles. So the fundamental principles that we see in Lab 2 are very similar, or actually the same as what we see in Lab 1. We still use Coulomb's law, the gravitational force, and the electric field. We also use superposition, which is when you divide a charged object into segments, then add together their electric fields to get E net, or the net electric field. Initial conditions and assumptions. By the way, a lot of these initial conditions come from Lab 1. The length of the tape was 0.2 meters. The weight of the tape was 0.0002 kilograms. The distance was 0.024 meters. The system was tape 2, and the surroundings are tape 1 in the earth. And really, any of the other forces acting in the universe. Okay, and then to calculate Q initially, I used the equation below and got 2.49 e to the negative 8 coulombs. Some of the assumptions that we have in this lab are that air resistance on a moving object is negligible in this experiment. The U-tape had about the same amount of charge evenly distributed along the length of the tape, and that the U-tape can actually be separated into multiple equally charged segments, with each segment being considered a point charge. This is part 1 of my glow script code. And the first thing that I did was I inserted the physical constants that I would use throughout the lab, which included the mass of the tape. And I also changed Q to reflect what I initially got for Q as discussed in the previous slide. I also updated the function for the electric field so that we could actually calculate it. And then the right side of the code is what calculates the electric field and the electric force. This is the second part of my glow script code, and the rest of the code really shows how the electric force vector and the gravitational force vector are made. And then we see the results of my code. So the results of what my code initially puts out is highlighted in blue. And as you can see, the magnitude of the electric force and the magnitude of the gravitational force are very close together. They're very similar, which indicates that this is probably a more accurate model than what we got in Lab 1. Additionally, I also did a trial and error approximation to see if I can get the magnitude of the electric force and the gravitational force to actually be equal. And when the closest I could get was what you see at the bottom of labeled results of trial and error. And this Q was equal to 2.44 e to the negative 8 coulombs. You had modeled each of your tapes as a single point charge, like in the previous lab. Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. When I did this, Q would be equal to 1.23 e to the negative 8 coulombs as opposed to 2.44 e to the negative 8 coulombs, which is what I got in this lab. This is approximately a 50% difference between the two values, which means that the value that I got in lab 1 was almost half of what I got in this lab. Why do these estimates differ? Which value is more likely to be closest to the real value, and why? These estimates differ because in the first lab, we only focus on the tape as a point charge despite the charge being spread across the length of the tape. The value obtained in the line charge is more likely to be accurate because we consider the length of the tape as well as the fact that the charges are not concentrated at a single point but are spread across the tape's length. Conclusion. Ultimately, the charge tape's value that was obtained in this lab more accurately represents the accurate charge of the tape when compared to lab 1. We found this out by applying the idea of superposition and calculating the charge of the tape when the length of the tape and the charges distributed across the tape are taken into consideration.